Welcome, everybody. Today, we're going to talk about healthcare data analytics. It's a new paradigm. It's coming up very, very strong. We cannot be left behind as health records and information managers. We need to educate ourselves about what this is about and where it can take us to. So I have a brief outline that can help us cover this topic today. Remember, this class is introductory, so I will try as much as possible to introduce the key thing, stimulate us, encourage us to understand the direction we need to take. Okay, it's very important. All right, so the very first thing that I would like to say so that we begin to prepare our mind is that every health records and information manager, you can become a data scientist. In fact, it should be taken away by right now. The paradigm has changed so much. Nomenclatures are changing so much. You should learn to understand the trends in the future and jump into it as fast as possible so that you will not be left behind. So the field of data science today, because truth is, what is data? What is records? Record is data. Another word for data is records. Okay, and so long as we are in the health facility system, data scientists is our business. We are data scientists. Now, if you look at data science today, much talk about it, much talk about it. Please do not ignore it. Don't think it's something that has to do with some people who are just doing data out there. You know, this is for some people that are not health records people. Okay, it is for you. In fact, there is no one that sits in this position than you. You understand why now. Now, under the field of data science, there are three major categories out there that people have seen to be an aspect of data science, and they are finding specialization in them. One is data analytics. It is a means by which we try and make insightful, meaning of data. Some data will just be there. You'll be there staring at the data is staring at you. You need to grow to have an eye that can see data and bring out meaningful insight from it. That's the sense that data analysis is all about. It's more of analysis, there's statistics in it, there's mathematics in it, there are quite a lot of things in it, okay? So we have another important aspect of data science, which is machine learning. Machine learning is the system of use of artificial intelligence, the subsector of artificial intelligence. We use a computerized system, algorithm to build a digital system that learns from data, learns patterns, see the patterns in huge data. We rely on these patterns and we use it to make informed decisions. Okay, so the trust of this is on the computer, the algorithm that is put into the computer too. We can actually enter into this field and explore it for healthcare, okay? It's very important, so we need to know that it's something that is within our purview. We can do it because we sit on records, we sit on data. That's our business, that's us. So we can't leave it to other people who don't even know the basis for data. You have a license, you have a license to protect the confidentiality, the integrity, the safety, the security of healthcare data. It rests on you. You decide on what should happen to it. So you can't fold your hands anymore and think that somebody is going to come and do it for you. You have to delve into these aspects. Okay, you have to become professional in it. You are a data scientist right now. So this is a picture. Data mining is another important aspect of data science, okay? It has to do with whether you're doing it manually or you're doing it with some kind of software. You go into very huge data set and extract usable data, okay? So you have a huge data set, you look at those data that you think would be useful for you to answer certain questions or to raise further questions or to gain deeper insight, okay? The technique for extracting this data is very. Who else can extract data if not the data manager? A health records professional information manager is a data manager. So who should mine the data if not him, really? Who should come to him and ask, please, I need you to mine out some data for this? It's you. So You understand the reason we say the future nomenclature for you today is to be a data scientist. Let me also buttress on this further a little bit. I think one very interesting way to describe analytics for us to understand is to make comparison between statistics and analytics, okay? So that maybe when we understand these two different, because there are two common things that have been happening around in the healthcare industry also and in everywhere. We find statisticians coming in to take our position, which can be, because as a health records person, you are also a statistician. You can be a statistician. You are a data scientist and a statistician. Okay, you can be a statistician, data scientist. Now we find people coming, they do analytics, they call themselves data analysts. They don't even have any single knowledge regarding the healthcare business. And they come into the healthcare system and they tell you they are data analysts because they can do analytics. We also can do analytics. Let's understand how it's done. And we can do it. We can do it even much better. And we can answer the questions within the healthcare field much better, much faster than any other person. So we need to understand what these are. So let's compare statistics, statistician, and analytics, and somebody who calls himself an analyst, okay? The analyst is somebody who does analytics. So a statistician is someone who conducts statistics. Both statistics and analytics are based on the foundation of arithmetics, mathematics, and statistics. Remember, statistics is also a study of its own, okay? Separately from mathematics, okay? Arithmetics is the smaller version of these two big brothers. Okay, so we all rest on this. But let us understand what a statistician, what he does, and why he's different from the analyst, okay? Or the person who becomes an analytics expert. Okay, the statistician starts by asking questions like, is there a significant difference between this and that? Okay, and then he coordinates the analysis. He's the one who's going to get the data, who's going to come and put the data up, he's going to look for a test that will enable him answer this question. For example, he's going to look for t-test, chi-square test, you know, that he's going to use to coordinate and run the analysis and answer the question. He ultimately wants to make an inference, draw conclusions. Okay, there's a significant difference. There's a p-value. The p-value is less than 0.05. Remember all this stuff? Okay, fine. So that's a statistician's business. He does that. He's very good for research purposes, for academic work, for publishing documents, for taking very incisive, conclusive decisions on certain issues so that he's just so rigid. That's just it, compared to an analyst, okay? The analytics, you grow into exploring possible questions. That's what you do to data. You trash the data, you trash it, you visualize it, you use software. So the power of the analyst is software. You have to understand that once data is growing huge, the statistician uses very small set of data. You know, small set, as small as census data. Census data seem to be very huge, but compared to what we call big data, census data is still very, very small, my dear. So we're talking about big data. Big data meaning, think about National Hospital, for example. How many patients come in? How many go? How many are babies? How many are women? How many are married women? How many are those who went to pharmacy? What kind of drugs do they take? Amalgamate, aggregate all these data sets. How many doctors saw some patients? How many patients of those doctors went to the pharmacy? How many of them eventually took X-ray? How many of them are coming back the next week? How many of them have died in the course of all these are data that become so huge and huge and huge that in one day, millions of data have actually passed through the hospital setting. Think about National Hospital, for example, okay? And you understand exactly what I'm talking about. Or University of Ibadan Teaching Hospital, for example. Oh my goodness. So big data happen there. So you need software as an analyst. Conducting analytics, software is a great strength because it will help you to do visualization easily, explore possible outcomes, refine your question. That's the basic thing that the analyst does. He refines the possibility of question that can now help the statistician to want to try and draw conclusion. That's what we do for them. So we create the basis for inspiration. We create the basis for deeper insight. We don't We don't like go ask one question and go, no. We explore the big data. We see patterns. We present the patterns. We tell you the likelihood. We tell you the possibilities. You know, it's a world of unending possibilities. That's what it is. Okay, so that's the picture, and that's a setting for the analytics. Okay, so we want you to have this picture. We want you to have this idea. We want you to have this knowledge that you can be an analyst. You can do analytics. You are a data scientist. You are all of this. Let's look at it, okay? I hope this makes a little bit of sense so that you understand the difference between a statistician and what you do as an analyst in analytics, okay? So with this, I would like to encourage us to understand that the future is for the data scientist. The portfolio of a health records information management practitioner is, first, he's a data scientist. So don't put yourself in one box and think there are other people that are data scientists that are not you. It's not possible. It's unthinkable, okay? So you're first you're a data scientist, and you have all these activities under you. You're a data manager. You understand what it is to be confidential. You keep files, you manage them, you collect them, you collate them, you save them, you store them, you retrieve them, you process them. You're a data manager. When research comes, you conduct statistics. You do basic statistics. You find mean, median, value, averages. You do tests for significance. You can do it. So you are also a statistician. You're a data miner. For example, you manage this data. Somebody wants a set of data. You give that person that set of data. It's easier to do in an electronic system anyway. Data mining, like I said, we cannot define data management henceforth. You have been barred from defining data management henceforth if electronic or digital system is not involved in it. Sorry, you're not defining data management. And so mining today is also possible with software. You can extract data from a huge set of data and give it or use it for processing, analyzing, understanding, visualizing, you know, making deeper insight as an analyst. Again, you can become a data machinist. You can delve into the field of artificial intelligence. It's open to you for healthcare purpose. It's open to you. You manage the data, so why can't you go into artificial intelligence and become an AI expert in data machine or data machine learning? Again, you can become the data analyst and then do data analytics. Okay, so we're going to learn a little bit of this today and understand how the key skills, traditional skills that you need to become a data analyst today. Now, but first of all, let us try and understand why data analytics is very crucial for healthcare, okay, healthcare business. We can do a lot of things for healthcare. The key thing here is in healthcare business, we try to save lives, we try to improve well-being. And that's why the data manager, the data analyst, the data scientist, the statistician, which you are, can help the system have insight beyond these classical indicators. Remember, well, we have been bound to understand indicators. Yes, of course, this is part of our primary assignment. Produce results of the classical indicators that you are working with in the healthcare industry. Of course, those indicators are key. They're paramount. They help us get deeper insight also. They help us take decisions on the spot. You remember those indicators: bed occupancy, maternal mortality rates, you know, all those key things, immunization rate, uptake, all that, basic things. These are indicators. So, but beyond these classical indicators, you want to crunch big data. You want to interrogate big data, and you want to do it with speed. You want to do it with high accuracy. You want to come up with descriptive analytics outputs that can generate deeper insight to people, to your managers, to the health system, to the overall health system of the country. You want to also help to bring about cost reduction. You want to do that by, you know, running certain predictive analytics. Okay, I have a paper there that describes this, so please try and read it up. You understand what predictive. You want to try and see what will happen tomorrow. The pattern has shown that this person is doing this, this person is doing this, this person is doing. He does it this way. The data shows the pattern. This is how they used to behave. And if you look at this data set, you would see the behavior. And you can tell, okay, on Fridays, you will see NHIS people coming here. They go through the back door. They appear in the pharmacy. They take their drugs. They always go from drugs. They always go to radiology. I don't know what they are doing there. If you look at it very closely, you will see that there are some HMOs that come in and take pharmacy and do radiology. You will see that pattern. You would want to ask, is it because they have premium? Is it because they are free? Is it helping their business? Is it? A lot of things can happen. And we can do prescriptive analytics for it too, okay? We study patterns, we see how, what kind of prescriptions have helped the system to run better and faster. And the data trend can tell us people have recovered from certain diagnostic processes, surgical procedures. All this information are embedded right in our hands. And we can crunch a lot of it, we can interrogate a lot of this and bring out interesting insight that can help the system to move forward, okay? If there's anything that drives the system today is cost. Financing healthcare is a very tough area to look at, and we can actually help the system a lot if we sit up tight and do what we have to do. We don't have to leave it to economists. The economists do analysis. The health financial expert to do this same analysis. It's a matter of building the skills to understand the kind of insight you have to bring about to help managers and decision makers take that decision that they need to take. That's just it. Okay, so, and it's not rocket science. We can do it. All right, so these are some of the key things that we need data analytics and healthcare for. And quite a lot of others, okay, you would see, but these are quite key, they are crucial. But let us start with the very basic. Assuming you're seated on Microsoft Excel, remember, I cannot imagine that somebody is a health record information manager and a professional, and he doesn't know how to move around Microsoft Excel, okay? So let's start from here first. Let me first of all start from here. It will give us insight into understanding those add-on software, add-on or standalone software that I use for managing data, manipulating data, running analytics, seeing visualization, transforming, and doing all that thing. Okay, so first, traditional skills for anyone who is going into data analytics. Key traditional skills is data manipulation. I know that we've heard this word manipulation, and sometimes it spells like manipulating data is like something bad or something wrong. Somebody's doing something not right. Is that what it means? No. In fact, there's a software that Sigma Excel, okay, is used for Six Sigma certification program. In fact, in one of the menus on that software add-on, it's an add-on on Microsoft Excel, by the way, and it has a menu called data manipulation. Okay, that's to tell you that the word manipulation is not something negative or wrong or bad. We need to understand that. You can use this term very well. As a data scientist, you can use this word, okay? But a softer landing for it is transformation. Data manipulation, data transformation are almost similar. Okay, so you have to have this traditional skills of understanding that all data, the way they appear in raw form, can be transformed. And we transform them to make it very easy to sit in a position where analysis can take place and you get this deeper insight of this data as you would want it to be, okay? Data transformation is a key traditional skills that anyone who wants to be a data analyst or an analytics expert, you have to understand the concept of transformation. Transformation is the ability to change the form of the data. We'll see example, you can change the structure, you can change values. It's just like coding. Coding is a form of data manipulation. It's a form of data transformation. You transform the disease condition into codes, okay? So it conceals a lot of important things, also that only those who are specialists in that area are open to understanding that. That's another means of confidentiality. That's another means of improving the quality of data so that we are not wrong. There is no ambiguity. Once you see a coded a medical coding of a particular disease condition or the diagnosis that has taken place. It is very clear. You understand what it is, and that in itself is a form of data manipulation, okay? So these are key strengths that you have to be able to perform well in analytics. Now, the second important skill that you need for data analytics is data visualization skills, okay? Interestingly, Microsoft Excel has come in with very interesting feature. Now, visualization is something it is something that works with the back brain of the human being. I need to say something very, very little about this, okay? When you see data, figures, tables, you know, they just sit down there very hard, you know. But when you see figure, charts, it's like looking at a picture. It's like, you know, gazing into the sky and you see the sun piercing right through the clouds. It's telling you the story right away. You can see that in the weather forecast, 35 degrees centigrade with some kind of figures there. It's not the same as when you go out and you see the picture. You see, so the picture comes to life. It helps to tell the story faster, better, you know, in interesting graphics. So we can use maps, diagram, plots, like you can see on the slides, okay? So it's a very important skills you need to build to be able to have good standing as a data analyst, okay? Analytics. It's very important, okay? So these two skills, we would see how you will be able to do all that on Microsoft Excel, okay? So, and like I said, again, if you cannot work on Microsoft Excel and you call yourself a health records and information manager, my friend, think about it again. Just crawl quietly and go and enroll in one basic Microsoft Excel class. Otherwise, you cannot even begin to start to call yourself data scientist in this new world, in this new era that we're in. Please, just crawl quietly. I'm begging you, because you'll be out of space in no time. And I don't pray that we're out of space, because it is unthinkable that somebody who is a health record information manager, a professional, and then basic Excel is nowhere. This should be the first thing. We need to move with speed. Most of the courses that will be uploaded on this for our professionals in time to come is to help, you know, move faster beyond this. And most of them we will do on Microsoft Excel, because even if you work with EMR in your facility, you may want not all the EMR give you those details analytics. EMR does analytics, but not really detail as we would want them. So you will need to export some of this data from the EMR to Microsoft Excel. Microsoft Excel is the first landing stage landing point for all data that are exported from your EMR. So once it moves there, you can now do further analysis, you can trash it, you can visualize, you can manipulate, and you get deeper insight. We'll be able to have time for doing that maybe much later, okay? So one key skill is data manipulation, data transformation. Second key skill is data visualization, in which you use graphicals to look at, trash the data, transform it, and you look at it in graphical forms. These are two key skills you need to be a good data analytics or data analyst, okay? Which you can be, all right? So with that being said, I'd like us to look at a case scenario, okay? So that maybe it will help us to begin to understand what it is that we do in analytics that helps to, you know, find solution in a healthcare system. Okay, I have this scenario sometime back when I was working in the hospital, and there were patient complaints coming from different left, right, and center. Okay, and one of the major complaints, we are very familiar with this. This is just an example. It's just an example. Remember, case Vignette is just an example. There are several other examples. I just want us to use this to, you know, to learn something today. So there were patient complaints here and there. Waiting time is a major one, and across many service centers, pharmacy waiting time, lab waiting time, consultation waiting time. You understand what I mean? You go to X-ray, long waiting time. So And the management is under resource constraint. You don't have staff. Infrastructure are not there. You understand? So what do you do? How do you manage the little resources you've got? And how can you, as a records person, the data analyst, the data scientist, come to the rescue? This is where you can play a role. Who else can play a role in the hospital if not you? You know, come to think of it, you sit right on top of every single data that enter into the hospital. And then complaints are coming up like this. And then you're seated there, you're waiting for somebody because you think your own is to write, register new patients, jacket the thing, carry the file, walk into the archive, shelve it there, do wrong shelving, come back, spend weeks. Yeah, no, today we are trying to update our shelves. We are trying to validate the shelving. And excuse me, with HND, excuse me, you're beyond that. In fact, I had found a course to discuss with some group of people as HND, registering patient in front. Excuse me, you're an officer. You need to do more than that. So these are the kind of things you need to listen to within the system and try and take position and shake tables. All right, so there's this complaint, there's this scenario, and what do we do? What do we do? So this is what we're able to do at that time. We got a data set for consultation load. Okay, this is a radar plot. This is called a radar plot. You have to understand a lot of plotting system on Microsoft Excel. This is done on Microsoft Excel. Okay, so what we did was we tried to look at consultation load, like how the trend, the pattern in which people come to the hospital. So first of all, we exported the data from the EMR, how people come to the hospital, what time they come to the hospital, what time is the thickest, heaviest time. And the same thing, we looked at laboratory, we looked at all the spam, just putting two major components of the aspects of the areas where people are coming into the hospital. So first we had data. The data didn't come night, day, 10 p.m. like that. No, we needed to transform a set of data to bring about this. And then the data didn't also come with Monday, Tuesday, Wednesday, Thursday, as you can see. You can see the legend by the side, Monday, Tuesday, Wednesday, Thursday, Friday. Okay, so, and they have different colors and they matches with the color that is on the radar plot. Okay, so let's look closely at the consultation load, for example. So during the night time in a day, you see that very small, about there's a 500 patient load, okay? And we're seeing the highest load around 10 to 12 noon. Then we see the next huge load around 12 to 2 p.m. This is trashing. You're not answering any question. You're only exploring your data set to see and visualize. There was a transformation that took place and then now visualization of how the load happens. This is what the analyst does. You can do it. Who say you can't do this? So you present this to management and try and raise questions. They will now start raising questions. You are helping to refine the question. So what will happen? Now look at the thinking. People come to work at 8 a.m. and close by 5. Meanwhile, you will bring in 10, 20, 50 people to come to start work by 8 when the load is from 10. And then maybe you only have 2 or 3 doctors. Anyway, from experience, this is what happened. We decided to rationalize, because look at, we said there are 2 constraints: staff strength constraint, infrastructure constraint. Maybe no offices, no consultation rooms. Okay, so we needed to expand the consultation rooms, and then we needed to change the resumption time for some people. Somebody comes to work. Why should I put 5 people to be working in the night or 3 people working the night when I can deploy all of them around 10? So we also even changed resumption time. 2 doctors can come and start work from 8 to 10. The remaining doctors will come and start work and join the others and convert some places into consultation rooms. So within this period, there were the times when fresh hands are now resuming, deploying those that are doing nights. Let them come and join and start doing morning. So you become more efficient, you become more effective. The complaints will reduce. The processing time but these are initiatives that needs to be taken. But you need hard evidence. You need this kind of visualization evidence to help people to now think and ask questions. If you present this as an analyst, you may not ask a question, just go your way and see what will happen to management. Oh, you say, so, or they call you, Rogers, come and explain. So what is this? Well, it's showing that the thickest time is the highest load time. And I have a schedule of roster saying that only 6 doctors work and they resume by 8 o'clock and they close by 4 p.m. And then this is the biggest time. And then I see a roster where we have 4 doctors around 6 to 8, they work the night shift and they are only seeing less than 200 and 300 patients. So when you're just surpassing this, your points, it becomes very easy to rationalize the staff strength. It becomes very easy to consider opening 2 or 3. You put up all the information. You can suggest rooms that are already there, redundant. You can do this. You can help them. You don't take it, you don't decide, but you can tell them what happens. Now, if you look at this graph very closely again, you would see, for example, the consultation rate, you will see that the red is actually on the tip of it, meaning on Tuesdays is the highest day of the load. So you will run this kind of analysis for three months in batches, like 4 quarters in the year, so that you stabilize and establish it. The next thick line you're seeing there is the purple line, which shows Thursdays. So for this particular clinic, it may be different from any other clinic. So for this clinic where you see Thursday, you see Tuesday, you see Thursdays. And if you trash this data deep down, you will see that maybe these are NHIS or HMOs of some sort. Look at Saturday, for example. Saturday is right there in the middle. Sunday, of course, is small, right there in the middle there. So Sunday is small. And for Saturdays, look at Saturdays. Saturday is thickest on between 12 to 2 p.m. Look at it. So if you want people to come to work and be more effective and efficient for the system and provide quality service to people, why bring them to come on Saturday night? Look at Saturday night, for example. It's almost very thin. It's as good as Sunday. So you can rationalize your staff strength and this way, move them to work around this period, the time of the greatest need. Okay, so this is what we're talking about. So this data analysis will enable you do this kind of analysis and come up with deeper insight that can enable people to take this decision. You can do it. We can start with Microsoft Excel. We can do this kind of radar plots. We can do it for scheduling, timing, and day or week, and see exactly what patterns and the visuals we're getting and how we can ask deeper questions from this. And then maybe the statistician, is there a significant difference between 10 to 12 p.m. and 12 to 2 p.m.? That's statistician business. The analyst can bring about all this kind of trashing and interrogation of the data and come up with, very interesting insight. So thank you so much for listening. I just hope we've been able to get a better insight into what analytics is. And for healthcare,